Alright, today we're looking at what's known as the quadratic formula. So if you have, and this is general form, ax squared plus bx plus c equals 0, to solve that you need to factorise in some way. Now if you've got something that you can't factorise easily, you'd need to complete the square. So this thing, the quadratic formula, and you can look in your book on page 112 if you want to see how it's done. But if we take this and we do the complete the square thing on it, what we end up is we're getting, and factorise it by completing the square, equate it to 0, what we end up getting is that this thing called the quadratic formula, and this is what the quadratic formula is. So the x values that would make that equation equal to 0 you get given by negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that thing there is the quadratic formula, so we can use that, and the quadratic formula works on everything. It may not be the most efficient thing for simple factorisings, but ones that are more complicated, that works fine. Now the thing with the quadratic formula is that part of it, and if I split it up, negative b on 2a plus or minus the square root of b squared minus 4ac on 2a, so I've split it up, plus or minus I should have there, then we've got this number here that we're adding and subtracting from. And because, as we know, haven't written all that very well, but because parabolas are symmetrical, that's what that's supposed to say, then we're adding and subtracting from some number. So what this part of it, the negative b on 2a bit, that's actually telling us the axis of symmetry. And so, of course, that's also the x value of the turning point as well. Alright, so for things that are a bit more complicated, we can use that rather than doing the completing the square. So let's have a look at a couple of examples. Alright, so here's our first example, x squared minus x minus 1. So rather than us completing the square, what we'll do is we'll use the quadratic formula. So a is the number in front of the x squared, so in this case there's 1x squared. B is the number in front of the x, in this case minus 1, it's minus 1x. And c is the number on the end, which is minus 1. Alright, so remember then that x is the negative of b, which is negative 1, plus or minus the square root of b squared, negative 1 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2a, which is 2 times 1. Alright, all over 2, and so that tells us that x is 1 plus or minus the square root of 5 all over 2. So that equation up the top there is equal to 0 when x is either 1 plus square root of 5 over 2 or 1 minus square root of 5 over 2, and there are our two examples. So we can use this to work out whether work out x-intercepts and work out what the x value of the turning point would be, and then we can use that and we can sketch the graph. So let's just do a quick example of that. Alright, so here's the one we're looking at now. We're looking at y equals negative 3x squared minus 12x minus 7. And so we want to sketch it, so let's do the easy bit first. The easy bit's the y-intercept. And the y-intercept, of course, x is 0. So if we put that x equals 0, of course it's minus 7. Alright, so we've got a y-intercept there at minus 7. Alright, so the next thing, of course, is the turning point. And so the turning point is on the axis of symmetry. And so that's x equals negative b on 2a. And in this case, it's the negative of negative 12 over 2 times negative 3. So that's 12 on negative 6, which of course is negative 2. And so to find our turning point, we know what the x value is. So to find the y value, we put negative 2 into that, so it's negative 3 times negative 2 squared minus 12 times negative 2 minus 7 on the end, and that comes out to 5 when you work it out. So our turning point is at negative 2 and 5. Alright, the last thing is to find our x-intercepts, and our x-intercepts occur if we use the quadratic formula. It's negative b plus or minus square root of b squared minus 4ac. It's a bit messy, trying to write with my finger. And so when we put those things in, the negative of negative 12 plus or minus the square root of negative 12 squared minus 4 times negative 3 times negative 7 all over 2 times negative 3. And when you figure all of that out, that's 12 plus or minus, I've done a fair bit with that underneath there, so that's root 60 on negative 6. And so we end up with, when we simplify that third, alright, so because 4 goes into 60 and it goes in 15 times all over negative 6. Now of course you can simplify that a bit more, because there's a common factor of 2 that you can take out on the top. Oops, common factor of 2, and when you take that out on the top line there, you will then and then cancel, you will get 6 plus or minus root 15 on negative 3. Alright, now that's in a little bit awkward. So if I split it up, 6 on negative 3 plus or minus root 15 on negative 3. bit messy. That's better. So that first bit's -2, which of course, remember, that's our axis of symmetry. Got the negative there. And all that does is positive changes to a negative, and that negative changes to a positive, so it's still plus or minus root 15 on 3. All right, and you can work out what they all are, if you like. But what do we know? All right, drawing on our graph, we know a few things. We know it had an axis of symmetry at -2, and let's draw one axis of symmetry down there. That's at -2. And we know the turning point was up here, because it was -2 and 5. So our turning point is up here. We know that it has a line set down here at -7. You can go back and look at those if you wish. And then, of course, so it goes through there. Oops, wrong colour. Goes through there. And so then, of course, it's going to be an upside down parabola. These x values here were the ones that we found there. So that one there, of course, is the -2 plus root 15 on 3. And this one here is the -2 minus root 15 on 3 one. Oops, -15, not -13. Better fix that one up. All right, and so that's kind of about all you need to do. It needs to be a little bit neater than what I've drawn mine, but other than that, that's what you need to do. So that's exercise 3H stuff.